to another episode with your favorite Project Leadway instructor, Mr. Spaeth. Today we're going to be talking about simple machines in the inclined plane and wedge. So we are going to start off with the inclined plane. Now we've already gone through mechanical advantage, what it is, what it means to have one less or greater than one, how to calculate ideal and actual mechanical advantage. So we are going to skip those portions. An inclined plane is just a flat surface set at an angle or an incline with no moving parts, able to lift objects by pushing or pulling the load instead of just lifting it straight up. So it allows us to put in less force, but we need to cover more distance. Okay, simple IMA for an inclined plane. The L, notice the length of the hypotenuse of the triangle that this ramp is making is 15 feet. That's the effort distance. That's the length in which we have to travel in order to push, in this example, the cart up the ramp. Notice the height then, being the our resistant distance is 4 feet, the height of the actual ramp. So finding the IMA, very, very simple, plugging in 15 and 4, so L basically for the length of our effort and H for the height that we're going up. Dividing one from the other, basically just getting slope, and getting 3.8 to 1 or 3.75 to 1. Super simple. Same thing with AMA. If we know force that it takes us to push and weight of the actual cart, again, putting those into our equation, getting an AMA, using our IMA and our AMA to figure out efficiency. Should be very, very similar to what we've seen in the past. Now for wedge, wedge is something we typically don't think about as a simple machine, but it's really just two ramps. It functions as a moving inclined plane. So the distance we move is from top to bottom, and then we move from side to side our output distance, or our actual resistant distance. So here we go again. Now I do need to make this really clear to you guys. This L and the H. Now it seems like they're switched around, okay? Especially in this orientation where we have the pointy end pointing up and down instead of left or right. But the L here is the distance of our effort, so how much we would have to push this wedge, say, into a block. And then our height is just the distance that we would be pushing outward at any given height. So if we push this wedge all the way in 10 inches, we would have separated, let's say, a piece of wood by only 3 inches. So finding our IMA, we would be putting in 10 inches worth of work. We would be getting out 3 inches, so 10 divided by 3, or 3.3 to 1, would be our IMA. So same equations, just need to have this picture in our head. If you're going to take notes here, this would be the picture I want you to put down, because this is very, very important as to defining mechanical advantage with a wedge. Another place, sorry, just to backtrack and say that would be very important to write down. Just make your little triangle here and take notes on which one is our effort. So our 15 feet being our effort distance and the 4 feet being our resistant distance. Good places to take notes if you want to stop right now. Okay, moving on. We are doing the actual mechanical advantage. Again, we're going to use forces that a question would give us. So these aren't something that we'd come up with ourselves unless we're doing this in the lab using our force gauges. If we put 250 pounds of force downward, our effort force, and we get 700 pounds outward, our resistant force, we would take our 700 divided by 250, get an AMA of 2.8. Again, we can do efficiency because we had IMA of 3.3, AMA of 2.8. Plug those into our equation and get an efficiency here of 84%. Hopefully you like this video. It's short and sweet this time. If you have any questions of what you should be drawing, again, these pictures here are really, really good references for you. If you have them in your notes for quick access, that would be great.